We're looking at pre-calculus, section 3-4, page 196, problem number 10. It has been an IOU problem that's kind of long overdue. Let's see if we can get this thing done. Um, Problem on the left side, uh, we have continuous compounding, $5,000 invested. The right-hand side, we also have 3% interest annually compounded. So that means once a year. And we are starting out, what you might look at as a head start. We get an additional $200 bonus. It's a 4% increase. So actually, we start with $5,000 of our own money plus $200 from the bank. So going forward on the right-hand side, we would start with $5,200 and we would have our base updated as 1.03 to the T power. Now, as we get to part B, as we just briefly arrived at this step in class on Monday the 16th, we would divide both sides by 5,000. So our coefficient over here is going to become 26 over 25. And if you want, you could go ahead and convert that into an exact decimal of 1.04. But now here's the issue that we have to solve. We have t appearing on both sides, and t is in the exponent. And we have two different bases. We have base e on the left and the base of 1.03 on the right. That will be our challenge, but let's go ahead and make that happen from the slide that some of you already looked at. We're going to undo the base e exponential on the left-hand side. We're going to take the natural log of both sides. So on the left-hand side, we're going to apply the natural log, and we're going to have those inverse functions cancel each other out, and the exponent drops down to the normal line of, and now we can see 0.03 times t. On the right-hand side, we're doing the same thing, but it's not quite as simple. We're taking the natural log of this product. Now, applying one of our three log properties, we're going to have to take the natural log of 1.04 and add it to the natural log of 1.03 to the t power. But as you can see from the arrow right here, that allows us to bring the exponent t out in front. And I would like to suggest right away we have the t now located, one on each side, but now t is no longer in the exponent. T is down in the normal line where we would like to find all of our variables, and we're well on our way to solve for t. To make the next step, we're going to subtract both sides by the value of t, natural log of 1.03. So we're going to subtract the right side by this, and we're going to subtract the left side. So we're going to have 0.03t minus t times the natural log of 103. We finally have t appearing on one side of the equation. On the right-hand side, we're left with the natural log of 1.04. There's no variable here. It is a constant. Either now or in the near future, your graphing calculator can turn that into a value. But that's not a big concern of ours right now. I might suggest we just keep going. On the left-hand side, we have t appearing in two locations. I would factor that out. I'm taking out the greatest common factor. So I'm going to factor out a t, and I'm left with a quantity of 0.03 minus the natural log of 1.03. And now that I have t in one location, on one place, I'm going to divide both sides by that quantity that you and I are now looking at. And dividing that to both sides, we're going to get the natural log of 1.04 divided by the quantity 0.03 minus the natural log of 1.03. Now, be very careful with this in the graphing calculator. If you're doing it all in once, and that's what I would advise, just make sure you're dividing the entire denominator one time. So you're going to have the natural log of 1.04 divided by the quantity as you see it here. Your final answer is about 89 years. So I'm kind of impressed with that bank that's giving you a $200 head start. It would be 89 years for the compounding continuously institution to catch up. That makes part C rather simple. If you're going out for 30 years, the $200 head start is the way to go. So 30 years, well, the advantage of starting with $5,200 should be pretty clear. Strongly recommend you could do a grapher check off of your Y screen. It might be easier if you do a numerical check, setting up a table. And on that table, you could quickly see when the data from the left side of the original problem would equal the right side of the original problem. That should be it for now. That completes the IOU. This is a nice challenging problem. I'd love to be able to sit down and do more like this because it's the application of how can we use this exponential and logarithmic work in the algebra world. Thank you. Hopefully you enjoyed this.